La diffusion vient de démarrer. Tous les participants sont en mode écoute seul.
Hello everybody, welcome to the webinar on OpenRadioss and ParaView. We are still waiting some attendees, so we are going to start in few minutes, so you can take a coffee. Thank you for your comprehension and see you in few minutes. I'm just going to repeat for the new attendees. Hello, everybody. Welcome to this webinar on OpenRadioss and ParaView. We are still waiting some attendees, so we are going to start in few minutes. Just take a coffee and thank you for your comprehension. So perhaps let's starting. Hello, everybody. I'm Karim Azoum from Teratech, leading the French National Competence Center of EuroCC. I'm really happy to introduce this webinar on high-fidelity simulation with OpenRadioss and ParaView. You are going to discover what happens when you drop your cell phone with simulation, with dynamic simulation, and something also really important. You are going to discover what is high performance computing simulation. We are going to talk also about MPI and OpenMP parallelization, also about rendering with high quality animation, and of course about open source software. The first part, talking about simulation with OpenRadioss, is going to be presented by Marianne Boula from Altair, and the second part, also talking about rendering, is going to be presented by François Mazin from Kitware. They are going to talk together during this webinar. Before perhaps giving the floor to François Mazin and Marianne, I'm just going to take 5 minutes to introduce what is the French National Competence Center. It's perhaps really important to introduce what we are and what we do. First, the French National Competence Center was created in EuroCC. EuroCC is a European project funded by the European Commission. The goal was to create 34 national competence center in 34 countries in Europe. The goal is to support the industry, the academic, also on the use of HPC, HPDA, and AI technology. In France, the French National Competence Center is led by Teratech with some partners INRIA, Surfrax, Crillon, and Romeo, and with the participation of 21 mesocenters. Our goal is to support industry, academia, public administration on the use of HPC, AI, and quantum computing. We propose different services. We support the industry and the academic on the use of this technology by realizing some proof of concept. Also, we propose a lot of training, a lot of technical webinar and events, and also we deploy a marketplace to permit to promote the services of our ecosystem. During this project, we support, I think, more than 13 SMEs making some proof of concept. Here, I have some delay with my slide, but perhaps it's going to happen. Okay. We support during EuroCC project 13 SMEs, and in this slide I presented 8 French success stories around some proof of concept in finance, environment, also healthcare, and engineering. Something also really important, in 2024, we realized more than 33 training on HPC, AI, and quantum computing from January to July. Most of this training are in face-to-face, but also in hybrid mode. Sorry about that. And from September to December, something really important also is that we propose 20 training on HPC and AI and quantum computing. Some are in red because we deploy some training in Croatia and also in Slovakia. And also something, oh, sorry, I have some delay with my slide, but sorry about that. And here you can see it's coming, the end of the 20 training we proposed during September to December. Okay, so I have a lot of delay, so sorry about that. Moreover, we also propose different technical webinar. We realized in 2024 more than 24 technical webinar on HPC, AI, and quantum computing. Something really important, of course, is that all the technical webinar and most of the training are available in replay throughout our web pages, but also accessible directly with our YouTube page. This is really cool. And the last thing I want to share with you is that we deploy a French marketplace to permit to techno provider to promote experts, but also companies, but also services, and on the other end, to permit to end user to have access to all the offers. Of course, it's only working for the French ecosystem, but it's something new and really interesting to share and promote services of the HPC ecosystem. So if you have some question about our services, etc., don't hesitate to contact me or Maryland Pensma. Now I'm going to give the floor to François Mazin to introduce this webinar. So François, you can share your screen. I just had something into your interface. You have a module question. Please use the module question to share your question. This module permits us to monitor all your questions. We are going to give you an answer to all your questions, but please use only the module question for your question, and use only the chat just to give like a link or to share something with the attendees, but not question. Use only the module question. Thank you very much for your attention. And now, François, it's your turn.
Great. Can you see my screen?
Yep.
Pierre, can you see the PowerPoint presentation?
Yep.
Or no?
Yeah. We see a blue screen.
Oh, okay. So this is not what I wanted to show. Yeah, is it better?
Yeah, this is the first slide.
Perfect. So thank you very much for the invitation for this webinar between Altair, Kitware, and CCFR. Okay. So my name is François Mazin. I work at Kitware. I am the director of scientific visualization in Europe. I'm based in Lyon, in France. My background is numerical simulation. I used to work in big companies like ANSYS and Siemens, and as open source software enthusiast, I moved to Kitware to develop open source softwares. And today, most of my focus also is on the Debian Linux distribution. So a few words about Kitware before moving to the technical part. Kitware is quite our focus is about developing open source software for science and artificial intelligence. There is about 200 people in the US and 30 people in France. And we are a very technical company where most of our staff are people with PhD, master, or any engineering degree. So as I said, we develop open source softwares. So there is some of our software, the biggest one. So today we will talk a lot about ParaView. Can you see my the mouse pointer when I move it? Right?
Yes.
Yes, perfect. So ParaView, a bit of BTK today, but there is lots of other platform. Maybe if you are a bit into development, you should know CMake in order to build the C++ code. But we have solution in tomography with TomVis or in medical imaging with ITK or 3D Slicer. And our expertise cover lots of platform from web, desktop, mobile, and up to high performance computing, which will be the topic of today. So at Kitware, we have lots of expertise in these topics of doing software for science data. We are people experts in computer vision, how to visualize, analyze data from sensors, many LiDAR, radar, sonar, and cameras, of course. We do lots of classic data analysis, big data analysis. We have a dedicated team for scientific computing, scientific visualization. This is what I lead at Kitware Europe. We have also a big focus also on medical application, medical imaging, which is a very specific part of data management. And our last expertise is everything around CMake, which means software integration, software development, software solution, because CMake is a whole ecosystem with C-test, C-dash, in order to make your software more robust. And the last slide about Kitware, because everybody asks, how do you make money with free software, with open source software? So we do not sell the product because this is free. But we sell services. This is our business model at Kitware. So basically, if you want a training on ParaView, you can call Kitware for that. If you have some issue, you can get kind of support contract with Kitware. If something is missing in your Kitware software like ParaView or BTK, you can ask for custom development, or also we also develop a dedicated application for a specific domain based on our open source module. For instance, a VTK-based application for nuclear data management, or to visualize, I don't know, electromagnetism or explicit dynamic simulations, this kind of thing. And our latest activities is to collaborate a lot with researchers and academics. We are part of many consortium in Europe for my part, in order to foster the research in the state of the art and to push them into robust solution in open source through the Kitware's open source modules. So that's basically the Kitware presentation. Today we will focus on one of our products, which is ParaView. So ParaView is a software dedicated to scientific visualization. So first, what is scientific visualization? So this is basically a two-step process. This is from your data, which usually could come from a numerical simulation like OpenRadioss, or from some sensors, or from some mathematical equation, for instance. You will have to extract some features, some way to get inside your data, and then on the second step to map this feature to some graphical representation, basically to some pixel on the screen. So BTK ParaView are dedicated to these two steps, and usually most of scientific visualization actually happens in the first step, how to extract meaningful information from your data, and I will demonstrate that in this webinar later with ParaView. So what is ParaView? ParaView is a software with some graphical user interface in order to visualize your data, analyze and visualize your data. And ParaView has a client-server architecture with let the server run with MPI in a distributed way in order to post-process very large data. And when I mean very large, this is several petabytes of data, for instance. There is no problem to do that with ParaView. Of course, you need to have the computing resources in order to make the computation like an HPC, but ParaView is dedicated and is very scalable in this case. So it's widely used in the industry and in research. This is an open source software. It's actively developed mainly by Kitware, but with lots of external contribution. There is some statistic here, and ParaView is now for many years is part of the standard software stack for every supercomputer in the world. Most of the top 500 supercomputer already run ParaView during their lifetime, so it's really widely used in this area. So application domain, ParaView is quite generic, as you would see in the demonstration. But so it means that ParaView could be leveraged in lots of application domain, from numerical simulation like fluid dynamics or particle astrophysics and so on, up to be able to analyze data also from experiments like in geoscience and so on, also to medical, or also to structural analysis, mechanical analysis. This is something that we will talk about today through OpenRadioss data. And just to end this ParaView short presentation, ParaView has a large ecosystem with a client-server architecture. So as soon as your data are running in a ParaView server that you can open it, you have access to lots of possibilities to interact with. So the classic desktop client is here. This is what I will show today. But there is lots of other bridges like web bridge. So you can also analyze your data through some web interface. Everything is scriptable in Python, so you can run some rendering and some analysis in batch mode. And with Python, you have the whole Python ecosystem, so it means that you can leverage any Python library, for instance, PyTorch or TensorFlow, in order to do some AI and machine learning and deep learning directly in ParaView. You have some connector also to visualize and analyze your data through virtual reality, augmented reality through OpenXR. You can also leverage Jupyter Notebook to connect to a ParaView, get the image, and interact through the Jupyter Notebook with some magic command. So it's very, very convenient. And one other bridge I like to mention is Catalyst, which is a way to do in situ analysis, which is instead of opening file from the disk, you will connect to your numerical simulation while it's running, and you will be able to post-process the data live from the numerical simulation memory. So it's very, very powerful. So this slide is to illustrate that ParaView is not just a viewer, it's a whole ecosystem, it's very scalable. So as soon as you can open your data in this ecosystem, you have lots of possibilities. So that's it for the short ParaView introduction. We will switch to Marianne for the OpenRadioss part, and then I will get back to you after the OpenRadioss data have been simulated and generated in order to post-process them with ParaView. So Marianne, the floor is yours.
Thank you very much for this nice speak and interesting introduction. So I will now start sharing my screen. So let me please know if you see my screen.
Yes, we can.
Yeah, not in full mode.
Wait
Full
a second,
mode
please.
with
So I will go into. Wait 1 second, please. I have to reorganize my screen.
Perfect.
Here.
Perfect.
Okay, great. So welcome everybody. And yeah, a few words to me. I'm Marian Buller. I'm since close to 25 years in charge of simulations, and since around about 16 years with Altair, and with since 2 years with OpenRadioss, where we have released Altair radios into and open sourced it. And I will spend a few words about radios and OpenRadioss. So, and then going to the practical application and this beautiful smartphone, which we are going to destroy virtually. So, okay, first safe harbor statement. Since we are a public company, I have to show it, but you can review it closely in the recording, so I will not go through these points. Where we are with Altair, so where simulation, HPC, and AI converge, so democratizing technology to deliver more power and drive better decisions. So we are taking care on artificial intelligence and high performance computing. So this is our business. And our vision is to computational intelligence will drive innovation for a more connected, safe, and sustainable future. So now coming a little bit to the application itself, I would like to start a little bit with the theory. First, implicit method, which means structural simulation, where most of the people are using today. So this is the equation, so which we are going to solve in structural applications for implicit, which is the stiffness matrix, and times and displacement is resultant to the external forces. So this is the main application used today. Anyway, if we go for and visualize how it is in terms of CPU cost and complexity, so things a little bit more tricky, because if the complexity is increasing, the CPU cost is also increasing dramatically for this kind of simulation methods. So for example, if we leave the static elastic domain in our applications, structural simulations go towards more nonlinear dynamic, like these drop tests and crash tests and so on, misuse cases. So where the complexity increases, our CPU cost is increasing so dramatically. Different case for the explicit method. So for static elastic cases, it's usually very costly, but if the complexity increases, the CPU costs are decreasing, and there's a certain point where we can go directly for explicit if the load cases become more dynamic and the complexity is increasing, which means more complex material formulations up to damage and fracture and so on. Here we can see it more clearly. This is a picture from the past, which I used also here. So for static elastic applications, where the velocity is close to zero, implicit method is highly recommended because of CPU cost. But if the plasticity, the nonlinearity is increasing, we are approaching plasticity, which means permanent deformation, buckling, damage, rupture, where parts can fly freely through the air, and going more towards dynamic, higher velocity. So explicit method is the best way, the method of choice, which we should use. For sure, today, this is not such a black and white border, so we have larger intersection here. Anyway, the higher the dynamics, velocity, and the nonlinearity, the explicit method should be used, computational costs. So now let's go for the explicit methods, because this is where we are solving now the equation of motion, which you can see here. We have masses and accelerations, which gives the force, damping, velocity, and stiffness elongations, which are providing the forces, which are time dependent, can be also zero, which means parts are just flying somehow freely through the air. So this is all possible. So one drawback is we have to have a time step which ensures the stability of the method, which is usually quite small. And you see now here the flow chart of the implicit method. We are in the time domain. We are computing the external forces, internal forces coming by the material models and so on, and doing the time integration in the time domain. So the loop here is infinite, which means the user has explicitly to define the termination time for this kind of simulation. So we are not doing we do not have any convergence criteria. This goes to in the time domain until the user defines the stop time. So what can we do now with this method? And this was done already in the past with OpenRadioss, for example, and now also with OpenRadioss. So let's go a little bit in the history where it all started. So we see here it started with the Dyna 3D code, which was developed in 1976. So which means already several decades old. And it all started here from the Los Alamos laboratories. And then here we are with Radioss. Here you see also the other solvers, commercial solvers like from ESI, PEM Crash. You see also LSDC, LS-Dyna, Abacus Explicit. So all these solvers are based on the Dyna 3D family, as well as here for sure Radioss. Also one point from the history. So the first full car versus car simulation was performed in 1991. So here we used it with within Adam Opel AG. So where Radioss was one of the first solvers which was able to do this car-to-car simulation crash. And now, since 2 years, we have open sourced it. So the question would be maybe, which is quite interesting, why did we do that? So because we want now to democratize these kind of high-level simulation methods, so accelerate the innovation in the research community, which tremendous benefits consolidating activities around an industry-proven code, maximize immediate synergy between leading-edge research and industry frontiers, building a high engaged and inclusive open source community involving researchers, software developers, engineers, educators. So everyone can now participate here from this major industrial crash code. Facilitate knowledge and model exchange. We have on our GitHub site also an area where everyone can upload also and contribute the models if he has some nice model which he would like to share. Everyone is welcome. And ensure the future, advancing FEA technology and modernizing the software platform.
Marian?
Regarding accelerate innovations, yes?
Marian, we have a question of Thor. How does the OpenRadioss codebase differ from the Radioss codebase? Are new features in Radioss also available in OpenRadioss?
Yes, this is a very good question. Thank you very much for this question. I will come to this in 1 second. This is really, I know these are points which are very interesting. I will explain it to you. So I will come to this in a few seconds. So please stay tuned. Very good question. Thank you very much for it. In one of the next slides, I will explain exactly these points. So do you still see my screen here?
Yeah.
Okay, great. So I will continue now. Okay, regarding accelerate innovation and what we are searching for are collaborations in strategic domains like material and failure models, which we still are investigating and developing. So we already have a large library of different material models, but for sure there is still a lot of space for improvements. Please contact me here if you have any questions. We still have demands on creating new damaged materials for material models, especially for batteries, for glass, for concrete, composites, tire models, and so on. As also for biomechanics and healthcare and safety, what you probably have seen in the users meeting 2 weeks ago in Philadelphia. There are a lot of activities ongoing on this side, especially for this new human body models like Thumbs, Piper, Viva Plus, Thor model, and so on. And of course, software performance, hardware, software, cloud providers, AI, machine learning, speed up computational times. So there are a lot of open questions and points where everyone can participate, like GPU and so on, phase field simulations, and many other topics which are still open. We have on our website, which is www.openradioss.org, you will find even more points under quick links like recent publications. You will find a download area and so on. And the open source version of Radioss. So the goal is to democratize the usage of explicit dynamics built on active community and accelerate innovation piece. So we released it 2 years ago. You will find all the details on our website, openradioss.org. Since we released it on the same days, so we got a lot of hits. So you see 43K of hits on the website. The community is growing very fast. Our code is on GitHub, so you can download the static libraries which are precompiled for Windows, for Linux. And we are also now supporting even ARM CPUs, which means you can run it on ARM CPU cluster or even on your Mac if it is using the new ARM CPUs. We have 250 forks and 2,500 contributions, including 100 plus code fixes, 250 discussion subjects on forum. So especially points, all kind of questions and discussions like here converting to D3 plots and so on, job submission, graphic user interfaces, which makes it much more easier to make use of OpenRadioss. And for sure, we have a YouTube channel where everyone is invited to review and also contribute content. So feel free to ping me and so we can discuss. We have already some videos on the first steps, so making it new users easy to download it, to let it run and play with this beautiful solver. Regarding Radioss, so it is an industrial proven crash code. initially used in the automotive industry. So you see here safety. We have nice, very advanced models for modeling airbags. Also full vehicle crash cases, like here this small offset rigid barrier crash case. Dummy models here, seat belts and so on. So this is used highly in the industry. For sure, crash cases here, like classic ones from auto industry, tank sloshing examples, composites in the aero industry with the high-speed bird impact, and even higher speed impacts on satellites from debris which is flying in space with ultra high speed velocities beyond the speed of sound of metals and materials. Also used in defense applications, but also for manufacturing simulations like forming not only metal but also sites and 3D additive manufacturing, and here this fluid structure interaction, which is also considered in the solver, as well as this beautiful cell phone, which we are going to break here in a few minutes. Coming now to your question, so what is the difference between OpenRadioss, which is the commercial version, and OpenRadioss? So this is now explained more in detail here. So OpenRadioss is an industry standard crash code, which is now open sourced into OpenRadioss. And OpenRadioss is published here at GitHub, so you will find this site also on the website. It is the upstream version with contributions from fast-growing worldwide community, which means OpenRadioss is the development version of OpenRadioss. So everyone can contribute. We have for sure checks, and we have a reviewer which will review each contribution closely. And we are taking care on robustness and stability. We have also introduced now a section with stable versions for people who just want to use it. We have precompiled versions for Linux, Windows, and we have here sections where the community is providing the support via the forum. So you can find all this here on the GitHub website. In addition to that, OpenRadioss is the commercial version. So here the license is also included. The commercial releases with extensive QA, professional support, documentation, and maintenance priority available under Altair Units license. Here we have also the possibility of encryption. So the encryption modules are also included because the commercial dummies and barriers which are provided by third-party companies are encrypted. So we can do it only in OpenRadioss because it doesn't make sense to put it in the open source version, because it could be easily bypassed. So therefore it's only available in the commercial version. And for sure channels valuable community contributions into industrial release. So which means all the developments which are done in OpenRadioss will find its way later also into OpenRadioss after a more extensive review process. So these are basically the differences. On the other hand, there are no limitations on OpenRadioss in terms of parallelizations, in terms of the size of the models, and so on, all the other features. So there are, beside of encryption, there's basically no difference.
Marianne?
One example was provided by
Marianne?
Yes.
Yeah, we have another question asked by Thor. Are there any plan to introduce GPU support on OpenRadioss? Yeah, this is a very good question. Since this code is developed several decades ago, if we would go for GPU support, so it has to be rewritten completely. So therefore, we are looking for sure, we are open to do this, but it is not considered for now because it is designed for CPU. And rewriting a large
code base which we have in OpenRadioss for being able to run on GPU. It's a huge effort, and so it's for now, if we find some people in the community, we would be rather happy and we would support them for sure. But for now, we cannot. It's not on our target, so we cannot do this effort because the code base is too large. But if anyone wants to help here and jump here, everyone is welcome to start with this initiative. From our side, we have it not on our radar. It's too much effort ongoing for GPU, for pure GPU. But this is a very good question. So thank you very much for this question. Okay, coming now back for example of the first contributor, which was already short after we have open source in, and from which is, or at that time he was a PhD student, and he has now his PhD, and he introduced his own failure criterion and added into OpenRadioss, and after we reviewed it, we merged it into the OpenRadioss source code, and now it is also released in Altair Radioss, so it has found its way from the OpenRadioss into Altair Radioss, so it's available now in both. So this is just an example that everyone can contribute. He was again a student from Malaysia and had a very nice, clever idea, and after his contribution, we also pushed it to Altair Radioss. We have a users day, so started 2022, but 2023 we had a nice and a larger one in Aachen, in Germany, where you still can find all these presentations and talks from the different people here, Daniel from DataPoint Labs, or Paul Dubois, or David Comper from ARM, and of course from our colleagues from Altair and other contributors, as well as from Kitware here. Bob did one nice presentation here as well. Alam Sarai did one, and all the other guys, where you can find these recordings on our website on openradioss.org. Just 2 weeks ago, we had our 2024 second official OpenRadioss Users Day, which was hosted by Alam Sarai at Temple University in Philadelphia. So, which was also a very nice, beautiful event with many presentations and nice talks. I'm still preparing and cutting the videos, and they will find its way shortly into the website. For sure, we are also now going to support the LS-DYNA keyword models, which people are using are in the LS-DYNA format, so DYNA 3D format, which we are supporting now. So you can submit your models either in the Radioss format, or if you have them also in the LS-DYNA format, you can do it as well. So this is a multi-year development, initial focus on crash and impacts, continuous improving and expansion towards fluid structure interaction, adapting Radioss to user needs and experience. Mixed input format is supported, so you can include both in both directions. Supported cards described in the reference guide, which means in the manual here. The number is increasing, so for sure we are still not supporting all cards, but the number is increasing on the daily basis. And here, one of our colleague from the community did a comparison with a small, simple tensile test for metal piece. And you run the same model in OpenRadioss as well in LS-DYNA and plot the resultant force displacement curves, and you see it's in very good agreement. Now, as the number of supported keywords is increasing, so you can run even more complex model in DYNA star key format. So, and the community is still heavily engaged and now also supporting the a D3 plot file, so which will be then created after the simulation is done, which means this is just by conversion of the animation files into D3 plot files, like we are doing it already for VTK, for ParaView, which I will show you to you in a few seconds. So, and future plans is also expanding compatibility to bin-out format. So here the community is also very active on that. Supporting HDF5 format and the Python interface, which is already included and now going to be extended. And as already mentioned, human body models becoming more and more important since the computational power is increasing, so we can deal with these quite large models, which are very good for investigating of whatever safety aspects on real humans. So here, most of the inner organs are also modeled. You see one from GHPMC, which is the commercial version, available in the commercial version only. But here you have also some free available human body models like Thumbs, Viva Plus, Piper, and so on. So this was also done by Suzvan. He did comparison of this Viva Plus model, and he compared the performance between the Alice Diner model and used the same one and run it in OpenRadioss, and you can see a very good agreement of the results for this very complex model. Collaboration between Altair and OVTO Viva Plus. So from the 1.1 release, Viva Plus Alice Diner input models are compatible with OpenRadioss and Altair Radioss version 2024. So this is now quite recent. Running the human body model with Radioss is as simple as including it into your Dyna format model. And it can be also included in Radioss block format. So you can include underscore Alice Diner, still using your old formatted Radioss models, or vice versa. So it works in both ways. So coming now to short conclusion, multidisciplinary collaborations like battery modeling, lightweight materials, aluminum alloys, biomechanics. So here we had a nice presentation at the OpenRadioss Users Day from one student from Canada who developed these active muscles, defense applications, advanced numerical methods, HPC, Manicores, CPU scalability, accelerators, AI, machine learning, reduced order models, DevOps, CI, CD, API, cloud, co-simulations and interoperability with third-party software due to the fact that it is open source, which means you can input or insert your connections at any point, in any area of the solver, and making kind of interfaces wherever you want. Okay, active community. I already talked about that in the during our recent Users Day, where we have had more than 300 registrations from all over the world. We have a steering committee which is taking care on strategy in terms of development of OpenRadioss. Here you see the members of the steering committee. There are people from academia as well as industry. For example, Alim Sarai, she's Professor Paul Dubois, he's an independent engineer. Christian Alter, he is a research fellow. Kank, he is a founder and CEO of SimRite, as well as here from Alstom, FIA, University Marcel, and Safran Tech, and so on and so on. Newsletter is also published twice a year and available on openradioss.org. LinkedIn community group, which you can join, so you are warmly invited to join. And we again the YouTube channel, which shows you how to use it in an easy way. And now let's go to the live demo, which I would like to show you. Now, how does it feel to use OpenRadioss? First, going through the steps like pre-processing. So I will show you just briefly HyperMesh simulation model and show you how we have now simplified the conversion from the animation files into ParaView, and then briefly opening it in ParaView, and at the end I will hand over to Francois, who is the expert in ParaView, for further post-processing. So let's get hands-on, because you would like to see some action. So this is now HyperMesh. You see blank, so nothing is loaded. So I'm going to import my solver deck, which is this beautiful cell phone. So it asks me a few questions, and after clicking on import, the entire model will be now imported, and here's my beauty. I can zoom closer in, review the mesh, the entire model. So I can see the load case, which is now here the rigid floor, modeled as a rigid entity. I can go further into the load cases. I see the initial conditions, which is the initial velocity downwards. I see also the gravity is acting. Now maybe more interesting features like the material models for this cell phone using elastoplastic piecewise linear model. In addition to failure criteria, here I'm using the failure criteria for this tempered or Gorilla Glass, or so this uses a special failure criteria to model the fracture of this tempered glass. So I have transformation cards to do the automated reorientation of the model, because I do not want to, if I want to have DOE studies or whatever stochastic analysis, I can do it automatically in the solver. And now let's get started with this model. After exporting it, we have created here a nice small graphic user interface where you can just select your key or the 00.rat file, which contains all the information about the model itself, with all the data showed here before that. So I open this model, I add here a number of threads if I want to go here on my computer, so I put just 4, and I check that I would like to have, after the run is done, conversion from animation files to VTK and the time history into column separated values, and add the job. So adding it here, the run starts immediately. I can create a queue where I can add several jobs if I do some modifications. And this is now live here. So it's starting running, and using 4 cores on my laptop. So I have 8 physical cores, so but I do not want to use them all because I'm still presenting here, and otherwise Radioss takes all the available resources which you add here to this model, and then so this would then not allow me here to talk with you, which I'm not going to do. Anyway, I have also shortened down a little bit the simulation to just 2 animation files, because the rest did already in front of and provided it to Francois. So we will just see the first animation files. After the simulation here with OpenRadioss is successfully done, the converter will start and convert the animation files which are created then here. So you can see them dropping now into my folder. Here's the first animation file started 1 minute ago. The time history file, which contains the energies, the forces acting on the rigid floor, and so on. All the values, so the global values and also section forces and so on are stored in this file, whereas stresses, strains, and damage values of the entire model are stored in the animation files. So, and That's going to be updated here. And after this is done, the converter starts automatically here because I checked these boxes. You can select all. So if you want to run the starter only to check your model, or in single precision, whatever, you can show your queue, how far you already are. And during the simulation, you see still the remaining time, which is just 20 seconds.
Marianne?
You see already we are hitting the ground, yes?
Marianne, we have two interesting questions about what you are showing.
Yes,
the
please.
first one from Alexander is, it is possible to share the file used in this demo in order to replicate this on our side, or are these files already available somewhere?
Yes, very good question. Thank you very much for this question. So here, just for your information, the runs ended with the normal termination, which is great. And now the converter is doing its job. Coming back to your question, very interesting question. Yes, this file is available on OpenRadioss.org homepage. So you can download this example already and let it run. So it's publicly available. So there's for sure, this is a very simplified smartphone, not containing all the details, but just as a demonstration case, it's available, yes. And thank you very much for this question.
Yeah, really interesting question. And the second one from Marius is, OpenRadioss is running locally on the personal computer, right? Is there unlimited usage of cores?
There's no limitation, of course. So you can run it on MPI, on a larger cluster, whatever you have. So no limitations. You can use Intel MPI or Open MPI and run it on a very huge cluster, as well as on your local machine, like I'm demoing it here live. And we have even now created the source code is able to be compiled on ARM CPU. And if you watch the YouTube video, you will see we are running it even on a Raspberry Pi. So this is all possible, no limitations.
Okay.
So thank you very much for this very interesting question.
And the last one question from Dmitro. Would be nice to see this example done directly in Gmesh instead of HyperMesh.
Yes, it's possible. I will not start it right now, but you can see we are supporting Gmesh also for mesh creation, and it's described on the website. If you have a look at openradios.org, we are mentioning all the freeware tools which can be used, as well as the commercial tools. So you are free to use whatever you want. And Gmesh is one of the preprocessors for sure. But due to time restrictions here, I'm not going to start it on Gmesh. I just wanted to start it briefly, just briefly in ParaView, just to show you. You see the actual date, so it's finished, and once started with ParaView here. So this is now ParaView. I installed it recently, and now I can go and solving the VTK file, opening it, and you will see the results here, which I created a few seconds ago. And with these words, I would like to hand over to you, Francois, because now you are going to continue with more advanced post-processing in ParaView. Thank you very much for all the nice questions, and I'm still here.
Yeah, perhaps, Marianne, we have also two other questions for you. Perhaps it's time for you to have this question from Alexander also. How would that work using command line in order to produce the VTK files?
Yes, very good question. It's described on our GitHub page, so you can bind it also as command line. So we created this small graphic user interface just for convenience reasons. But usually you can use your command line on Windows or Linux where you have to set up some environment variables and let it run in command line mode. This is possible, yes, or it's controlled by Python or whatever scripts.
Okay, and the last question.
Thank you very much for this interesting question.
And the last question from Marius. The file I'm running with OpenRadioss are not shared anywhere. They are saved on my local device?
Yes, as long as you download it and you run it on your local device. OpenRadioss does not have any connection to the net or whatever internet, so you can switch off all your internet connections and it will run, and it remains on your local machine. If you do not want to share it, you don't need to do it. We are using the AGPL license for OpenRadioss, which means it's the same license like you use if you're using Linux and so on. So it remains on your site. If you do modifications and keep it on site on your laptop, everything is fully okay.
Thanks a lot, Marian.
I hope I was able to answer your question. Thank you very much for this question. So, Francois, you can catch down the ball.
Yeah, did I share the correct screen? Can you see the ParaView right now?
I see your screen with your beautiful background.
Oh, okay. No, so this is not the correct one. This is should be the correct one, right?
Yes.
Oh, perfect. Okay, thank you, Marian, for the OpenRadioss presentation and for running the case. So I also run the case on my laptop, and so here I've just opened the PTK file you just showed just before. So one thing before diving into ParaView about the file format. So VTK. So the VTK is quite an old and legacy file format. This is ASCII based. So if you really want to work in ParaView, I really recommend to convert the VTK to a more recent file format. So we have two file formats. The first one is VTU for unstructured grid. So in order to convert, you have to select the file in the pipeline browser and then click on Save Data, and then you can select VTU, and it will generate a new file which will be loading more faster in ParaView. And the other file format that Kitware is working on at the moment is the VTK HDF file. So HDF is a container dedicated to HPC distributed file format and so on. So stay tuned. We are working on it. And soon you will be able to export your anim file to VTK HDF in order to get more performance. So once you have convert your data to VTU, so I will open what I have. So usually you have lots of VTU file or lots of VTK file if you want to stay to this. So in ParaView, if you open some file, the files are automatically grouped together according to the suffix, the number at the end. So you just have to select the first one, and everything will be open as a time series, which means that if you play the time, the file will be read one after each other, and you will be able to see the animation. So here it's running, but the movement is very slow, very small. Sorry. Okay, so let's discover a bit ParaView for people who are not familiar with ParaView. So the most important part of the graphical interface is here. This is the pipeline browser. This is where you open your data. This is where you run the analysis. This is where you add filters in order to get the inside the feature extraction I explained before. This is where everything happens. For instance, so the philosophy in ParaView is you have some data, some sources, like here the VTU file, and then you apply filters in order to do kind of post-processing, kind of analysis and then you display the output of this analysis of each filter. So let's have a quick demonstration. For instance, we have some filter in the toolbar here. Let's apply, for instance, a clip. So the clip I will cut actually the data if I click apply. So here we have our data which have been cut and displayed. And you can see here we have the eyes here, which explain what is currently displayed in the active view. And what is very powerful in ParaView is that you can display anything from the pipeline in the same view. So for instance, here, let's also display the initial data and tweak a bit the display to put some transparency. So here we can see very easily with one filter and to play with opacity, we can see what is inside and to have the whole model in transparency in order to get the context. And so, and the browser, the pipeline is kind of hierarchical operation made of the upstream sources. And you can add them and stack them. So, for instance, the output of the clip, I can add, for instance, another clip if I want to. Let's move it a bit here. And if I click apply, so here I will have my two clips here and the initial representation with transparency. So this is the basic. Yes, please.
We have a question from Alexander. Yeah. What renderer should be used to open the files?
I don't think that I understand what you mean by renderer. If you are talking about the rendering routines that ParaView uses, so there is some default one, which is based on OpenGL. And at the end of the webinar, I will show how to use some advanced one, especially with ray tracing and so on. If your question is more about the file format, so ParaView can open lots of file formats. If you click open, there is a lot supported from, yeah, you can see, and even, yeah, maybe 55 format by default. And ParaView has some plugin mechanism where you can add new file format, new feature, depending on what you are loading and so on. Med, for instance, this is the file format used by Salome and EDF. Slack is also a file format, and so on. I hope I get your question. Okay, so we saw how to add some clips to add some features to do some basic post-processing. So let's go a bit further in the interface. Let's also reset the rendering. So in ParaView, so we saw the pipeline browser and the property tab with the view display information, which display information and properties about what is selected in the pipeline browser. The other part is the view, the 3D view here. So there is lots of way to manage views. So you have tabs here, so you can have several views in parallel here. And to select a different type of views. For instance, here I open a spreadsheet view in a new tab, and in every tab you can also have the multi-view feature. So with the button here, so you can also add, I don't know, another render view here with the 3D, and you can add on again some new view here and display, I don't know, some statistic in the light chart view and so on. So it's very easy to play with the view, to add, to have multiple things, to experiment, and so on. Okay, so let's go back to the main view. So we have some data. Okay, we are engineer. We want to post-process OpenRadioss data. So we have a mesh. This is an unstructured mesh, and we have some fields on the mesh. So how to display the field? So you have to use this combo box here. You can see all the available mesh here. So by default, the node ID has been selected, which is an ID for each node in the model, not relevant here. So let's select, for instance, the velocity velocity on each point, and so if I click here, so the color changes, and if I play the animation, I hope it's not too laggy with the GoToMeeting thing, GoToWebinar, sorry, system. But you can see that everything is updated live, and you can check what is happening with your velocity magnitude. So this is how to select some different fields on your data. You have also different way to represent the data. So by default, this is a surface. So it means the visible surface is displayed with kind of OpenGL triangles. But you have a different way to represent it. For instance, in wireframe, if you want to inspect the mesh, you can have surface with edges, which is a combination of the surface with the wireframe, and so on. We have a rendering and so on. I won't go into detail today in this, but you can explore it very easily.
François? François,
Yes.
a quick question from Philippe. Is it possible to filter, for example, a few elements by ID?
Yes, and I will showcase it in a few minutes. Stay tuned. No problem. Okay. Okay. So yeah. So we can see different fields as we see. But okay, the color is okay, but it's maybe not what you are expecting with OpenRadioss simulation and explicit simulation. So with this button here, the edit color map, you can change the way you are mapping value to colors into the 3D view. So it opens the color map editor. So ParaView has a lot of color map available. You have few of them here as a shortcut. For instance, you can use the classic rainbow. Get some more modern one with like the one from Matplotlib, Inferno, or Veridis. But if you go, so you can edit it with by clicking on the button and so on. And if you go to the preset, there is actually a lot of color maps, and I want to showcase especially a structured one, which are very popular in mechanical engineering. So let's use the rainbow with some structure, some categories, and here we can see yeah, some classic color map. Maybe you are used to have in a HyperMesh, HyperWorks, and many other softwares. Okay, so we saw how to display some fields, how to represent them, how to tweak the color maps. You can also look at the display. You can play on opacity, on luminosity, and so on. I won't go into detail today. So we had a question how to extract some element. So I will showcase it. There is different way to do it. First one, if you know exactly the element you are interested by, let's for instance display on phone business. Yeah, phone business, for instance. In the telephone drop, of course, so we have some impact here, and the stress will be very large here. So you can, with the button here, you can select some cells interactively. When I move my mouse, sorry, we can see that the cells are aligned. So let's select one here, and I can either extract the selection, what I've been selected, or we can also plot the selection and the value of the selection. No, sorry, this is not the right filter. Extract selection over time and then plot it. So yes, and if I click apply, so it will go all through the time steps. That's why it's very interesting to have some fast file format like VGU or VTK HDF. Then it will extract the value at each time step, and it will display it in a graph in a few seconds. So this is one way to extract some specific cells, or you can do the same with points. You have several buttons in the top bar of the 3D rendering. and it will display. So it takes time. Yeah, that's it. We have it. And so it creates some line chart with only your elements, and in the display tab, you have everything that has been displayed here. So let's remove everything and maybe keep only the fun methods we are interesting, and we can see. If I play the time, you can see that we have some bounds, and the threads go up and go down, and you can get more insight. Okay, so this is one way to get some data from a specific cell. I want to showcase another way. For example, on this model, so let's delete this. We have the erosion status, which is a special field on some cells that explain is there a crack or not in the cell. I think Marianne will have a better explanation than me what it represents. But basically, when you run your simulation, you can see the crack progressing, and you have more and more and more and more crack. So let's imagine you want to extract the crack to understand exactly what is it. Just first, I would change the color map here. It's definitely not great to see. Yeah, this is better. So we can better see the crack here, the cracks here. So the other tool is the find data view. Find data is very convenient. It's a way to run some query on your data set. So first you have to select the data producer. So my phone, I will run I will run a query on the cell. I will select the field I am interested into, so the erosion status. And I will extract every cell where the erosion status is 0, which means that the cell has been damaged. Click Find Data, and everything has been selected. I can extract what has been selected. Click Apply. So here we have only the damaged cell, or I can plot over time also only the selection. This is very similar to what we did by selecting by hand the cell just before. So again, it runs all the time step, extract all the relevant values, and to display it in a graph in a few seconds. It takes a bit of time. I think GoToWebinar is doing some hooks.
Yeah, perhaps. So we can answer perhaps a question from Atta.
Yeah, please.
Is it possible to limit the legend?
Yes, definitely. You have some button right here. If you see my mouse with the arrow, the horizontal arrow. This is lots of feature in order to control what are the range of your color bar. Okay, I will show it to you right now. Let's display the 3D thing. Okay, we don't need the selection anymore. So for instance, if I play, I don't know, for Mises here. So here we have an automatic color bar, which is between 0 and 95. If I click here, I have some automatic rescaling, but if I click on the second one, I can adjust the value and say, okay, for my case, it's only relevant to be between 0 and 50, and everything will be rescaled automatically. And that's it. You have the color bar change, and everything which is up beyond 50 will be represented with the same color, which is the red.
François?
Okay. Yes.
François, we have a question from Philippe. Usually, we need to make different processing for sets of elements. Is it possible to use part definition from .rad file as separate result file?
So yes, perfect question. I will demonstrate it in a few minutes. Please be patient. This is great to have so many enthusiasm to use the ParaView feature. So I was just demonstrating how to extract the eroded cell, for instance. Let's also display this. It would be nicer to see. So we have a graph only on the eroded cells. And we can, for instance, filter what is displayed here. Sorry, I'm not selecting the right one. So there is definitely too many things. So we can again display some fun methods, trace, and so on specific to these cells. But what is interesting, you have the n, which is the number of cells in your selection. So basically, in our case, the number of eroded cells. So let's select it here. So n is not a great name. So let's change the name here. Number of eroded cells, for instance. So you can see the legend has been changed. And let's here you have a button to reset the zoom, and you can see the number which is increasing over time. And if you play the animation, you can see everything is updated live. Okay, I hope it answers your question. Okay, so go back to the question from I don't remember your name about part extraction. So yes, this is definitely a relevant question, because by default in the VTK and VTU extraction, you have a huge unstructured grid with lots of cells. With the VTK HDF file format we are working on at Kitware, you will have automatic part extraction. But at the moment, we have to extract the part manually. So in order to do this part extraction, we will again use the find data in order to run some query on cells, because we have the part ID field, which is very convenient because each cell has a number which corresponds to the part it belongs to. So we can filter on it. For instance, okay, I will maybe reduce it. Let's extract the part 1. So the part ID really corresponds to what you have in the RAD file. So if you open your RAD file, you can see part slash something, the number, and you can get the number. And if I extract it, I can see now I have only the part 1, which is the flow. And in my part 1, I can see that I have some lines here, which actually I do not really want for the post-processing. So I will show you another filter, which will be to extract cell by type. To select some filters, you have the filters menu here. So there is a lot of filters available. You have some categories if you want to discover them. And there is a very convenient shortcut, which is Control plus space, which opens a window in order to search for filter with a name. So in my case, I will extract cell by type, and if I click on it, if you don't know, you have some help. You can see the name, and you can see that the filters that are not available, and for each you have some information why it's not available. So this is brand new in ParaView 5.13, so you really have to try it. Extract cell by type. So in my case, I don't want the line, so I will extract only the quadrilateral here, and that's it. I have only macrolia. And let's rename it to ground, for instance, so I know what I'm manipulating. Okay, let's extract another part, the part number 2, for instance, and we try to be as fast as possible. So this is the case. Again, we have something we don't want, so let's extract cell by type again, and we will keep hexagonal and quadrilateral. Here you have some convenient box to look for element type. So let's click eggs. Let's click tetrahedrons, for instance, up and apply, and I have only my relevant part here. Let's rename it to name case. And for instance, you can, I know the part number 32, let me check, 32, yeah, this is the glass, so I will also extract it, and you will see we will get some nice rendering.
Perhaps we can take 2 minutes just to answer some question. A question from Ata. It would be interesting to see if video can be incorporated for correlation studies.
Video, I don't know what do you mean by videos. To run a videos frame by frame at the same time as the 3D model, right? Maybe.
I think, François, or crash, for example, to show at the same time the result of the simulation and the test recorded.
Okay, I see. I don't think we have out-of-the-box such features for videos, but if you have some image pictures, you can open a PNG, a JPEG, and maybe other kind of PNG image file that you can put at the same time, and you can have a PNG with a timestamp. So, and if it corresponds to the model, when you run the time, everything will be loaded in the same time, and you will add the image and the 3D model. So I think you can do it this way.
And we have another question from Yud Karsh. Is there a benchmark for processing speed of ParaView against other post-processors? Any estimation on how smoothly we can run on a computer with, for example, 8 gigabit of RAM and an i5 processor?
Oh, it's a good question because there is lots of parameters to consider here. First, in order to apply some analysis and so on, you need to have some RAMs because as soon as you compute some new data, some data extraction, it adds some data to your memory. So you need to have some memory on your computer. Also, you need to have some kind of computing power in order to do the computation, but the computation is done once. Right now, I did the extraction, and right now it's computing nothing. And the last thing to consider is graphical capabilities of your computer. So having some GPUs is great. Right now, for instance, I don't use my GPU. I am on a laptop. Oh no, I use I use my NVIDIA graphic card in order to ease the post processing. So this is the three things to consider if you want to post process on a laptop. But ParaView has lots of tricks in order to make it smooth and easy. For instance, when you open unstructured volumetric mesh, for instance, it extracts the surface automatically in order to show to you only what is visible. So there is lots of tricks. So I would say just try. Open your data and try, and I'm sure you will be able to do even some basic post processing.
And we have the end of the question. It's another question from me. Also, is there a scope of reducing rendering quality to maximize performance?
Yes, there is lots of settings in ParaView. So you can look at the settings here. In the render view, you can play with lots of threshold, lots of LOD. So decimation on the fly. You know, when you open very large data, when you move the data with the mouse, for instance, there is an automatic decimation. So less triangles are rendered, and as soon as you release the mouse, you have the full model is rendered. So there is lots of tricks in ParaView that you can activate or deactivate if you don't want it, and so on. And I haven't speak about client-server architecture, which is a bit out of the scope of this webinar, but also in client-server architecture, so all the rendering happens on the server, and you stream only images. And in this case, also we have lots of strategy in order to compress images, to stream as little as data as possible to make the experience as smooth as possible for the user. Okay. I will go on to have some time to show up to advanced rendering, or at least show how to point you in the right direction if you want to go this way. So to answer to one question 15 minutes ago, now we have 3 different parts: the ground, the case, and the glass. And for each part, we can use different fields to display. So for instance, the ground has no field, so we can just check some solid colors. The case, for instance, we can display, I don't know, the velocity, for instance. No, the phone meters, for instance, and the glass. Click on the glass here. and I can select the stress. That's it. And here we have different parts with different fields, and you can see you have a different also legend bar here, and you can also tweak the color of each of thing you are displaying and so on. So I hope it answers your question. Okay, so in the few last minutes, I want to explain how to enable advanced rendering in order to get some very nice image from inside ParaView. So here we have our three parts extracted. So we will activate ray tracing. So in the view or everything in property, if you haven't split it, you can click enable ray tracing here, and it opens a new menu. I hope it's not too small. Where you have different backends. So two from Osprey, which is the Intel technology, which use CPU, and one from NVIDIA Optics, which use GPU, the graphic card. So today I will demonstrate only Osprey, but you can also play with Optics as long as you want. So I activate the Osprey path tracer. So you can see the rendering has been changed a lot. It's a bit noisy, it's a bit blurry. So this is the first pass, and if I move a bit, the more array are computed, and that's it. And then we have some nice looking rendering made with ray tracing. And what is very interesting is that we have now some shadows. So in shadows is very important actually in scientific visualization for 3D model in order to see where are the parts, especially when you have lots of small parts. If you are already watch some CFD, for instance, where you have lots of turbulence and you are computing some isosurface with small parts, small droplets, and so on. So it's really great to have the shadows in order to have a more interesting perception of what is in front of you and back and so on. So here we have out of the box lots of nice rendering, but this is by default either the color maps or the solid color. So one thing we will do is to add some materials to our parts. So materials means lightning materials. So we have the materials editor here, and you can activate the shadow ball here, which gives you an insight of the selected materials we will apply. So let's start with the ground. So by default, we have a long list of default material here. You can choose, and you can also create your own material if you are into rendering. You choose the Osprey definition of material, so you can look at the Osprey documentation if you want. So for the ground, let's select some dirt, so you can see in the preview that it is really dark. So we select in the pipeline browser the ground, and I will click on attach here, and it will attach the material to my part, and the rendering will use now some dirt, and as you can see some okay, sorry for that. Some nice okay. Let's discuss now with the case. So let's the case we can add some shiny things. For instance, metal lead dull. For instance, not too shiny, but as you will see, it would be great. So select the case, click attach, and that's it. And we have some nice looking case around our phone. If I zoom on the case, we can see we have some sharp edge, which is not really nice looking. It means that we have not computed the normals of the surface to help the rendering. So let's compute this. So I will first extract the surface with a dedicated filter on my case, and also on the surface, I will compute the surface normals. That's it. And now you can see we have a nice round looking rendering our case. Okay.
François?
Yes,
we have a question from François also. Is optics included in the ParaView package, or has it to be installed separately?
Very good question. So in the official ParaView binaries, we ship optics. So it works out of the box. This is ParaView 5.13 that I just downloaded yesterday from our website. So yes. However, if you want to use, I don't know, maybe a recent version of optics and so on, you may have to build ParaView yourself. But by default, it's already a package. And about rendering, I can also mention in ParaView you have the NVIDIA Index also technology available for volume rendering. So in Manage plugin you have the Index plugin. Is it Index or NVIDIA? Yeah, PV NVIDIA Index. So you can activate this this plugin, and you can create a dedicated render view, which delegates rendering to the index library using your NVIDIA GPU and so. Okay, so now we have some nice looking rendering, but it's not incredible because the lighting it's very basic. So you can either play a bit with the lighting with the light inspector. I won't talk about it today, but I want to showcase how to add a skybox around your scene. So this is basically a 360 image around your scene, and to use the light from the skybox in order to illuminate your scene to make it appeal realistic. So this is something quite simple to do in ParaView. You have in the path trace environment to select image instead of the color to load an image. So I already prepared some nice looking image here. So it takes some time to load it because this is a very huge HDRI. And that's it. And we have an image around our phone, but oops, it's not in the right direction. Where someone maybe is throwing the phone, but this is not the OpenRadioss simulation we did. But and with the environment north and east here, you can change the orientation. So here my north is the axis, and that's it. And that's it. We are in the correct direction here. And that's it. And we have a very nice looking rendering here using a spray, your phone. You can add some mirroring material. This is what we use for the video, for the webinar, in order to get reflection and so on. That's it for your ParaView demo. I want to, so if you are really interested into advanced rendering, so Kitware did a dedicated webinar that you can find on YouTube and Vimeo with also an OpenRadioss model, yeah, the car crash. So you can definitely look at it and get more insight and more precision what you can do. I want also to mention some web technology you can use with ParaView. You can export your scene to ParaView Glance, which generate an HTML file that you can open in a browser and also visualize your data very easily this way. Also, you can build some application dedicated to scientific visualization and post-processing, and also create some web application to encapsulate the whole workflow, including OpenRadioss simulation and so on, with some technology we have, which is called TRAM. And in these few vignettes, you can see you can integrate some plots, some maps, some classic sci-vis rendering, or some engineering feature here. And about to go beyond just the post processing, I can showcase you can do very easily some AR and VR in ParaView. So in below, this is some OpenRadioss simulation visualized by Sébastien Villeneuve using ParaView and VR. We have some acoustic measurement here on the top, and some augmented reality with some medical imaging and some CFD simulation with the OpenFOAM motorbike. So it's very easily in ParaView. You have to prepare your scene as we did, and just load the right plugin, click one button, put your headset, and that's it. You are working inside your car crash. or your cell drop. I want also to mention that in ParaView you can run AI with PyTorch, TensorFlow, and any other library like scikit-learn and so on. And we have some big players in numerical simulation already using ParaView for this usage, like NCIS, Navasto, or even Neural Concept in Switzerland. So if you are working on a reduced order model or surrogate model, you can leverage ParaView in. Okay, so this is the end of this webinar. We are on time, great. Maybe for a few questions at the end. So today, what you learned from explicit dynamics use case with some meshing that you can do in HyperMesh or GMSH. As soon as you can get some RAD files, you can launch it in ParaView using the nice UI that Marian show with nice automatic extraction to VTK. OpenRadioss is very versatile for explicit dynamics with lots of application from automobile, consumer goods, safety, biomechanics also. And after your simulation, as soon as you have your VTK file, you can move to the ParaView ecosystem. So convert to VTU or to VTK SGF in a few weeks, and then start to do really scientific visualization. So extract information you need to do engineering, to do science, and of course to generate very nice looking image as we see here, in order to do some communication or also to get nice insight in your data. So I hope you find it useful. So a quick call to action. So what we showcase today is open source. So please go to openradioss.org, paraview.org, download all the software. Also, the cell phone model is available on the OpenRadioss website. So download it, play it, run it, yeah, and have fun with open source and to foster it for engineering and science. If you want to get in touch with us, you can use several channels. There is some dedicated linking page for OpenRadioss, also for Kitware and ParaView. Yes, there is a GitLab, the GitLab instance of ParaView also. We have ParaView has a very active discourse where we have a very live community answering your question and showcasing and so on. And of course, you can contact us directly by email. So there is some kind of community management of OpenRadioss, but you can also contact me, François, or Marianne directly with the email displayed here. And we will share the presentation via the CCFR website, so you will have all. And as a closing, lots of acknowledgement for people that made this webinar possible. People at Altair, like Eric, Sebastian, Marianne, we did a great job. Lots of people at Kitware. Here I'm talking on behalf of my whole team, the scientific visualization team. So thank you, Lucas, Louis, Mathieu, and Hélène also for the communication. And of course, CCFR and Tartec for the organization. It was not easy to get all of you today following this webinar, so thanks a lot for attending. I think we are done. We are maybe 15 minutes for questions. So Marianne and I are here to help.
Thank you, François. We are waiting for some questions. So if you have questions for François or Marianne, just ask your question with the module question.
I see AVI files.
Oh, we don't have a question for now.
Okay.
Ah, yes.
Which means false.
You have a question. Good webinar. Could you point to links about real-time rendering and movie making on your ParaView site? We are going to share everything. The webinar is going to be accessible in replay, and all the slides are going to be shared with all the points That's true, Francois and Marianne?
Yes.
Yeah. Of course. We will share everything. Maybe a few words about movie making in ParaView. So movie making is basically to create a sequence of images of rendering. So as soon as you are prepared your scene, you just have to go to the file and export animation, and then you export it either directly to AVI or OGG, or to generate some PNG for each time step, which I recommend actually, in order to do the actual video after with a dedicated software, and if you want to add some logos or things like that.
We have another question from Atta. Can hold RAD files work with ParaView?
So RAD file, this is input for OpenRadioss solver, if I'm correct. So no, ParaView cannot open RAD file directly. You have to simulate and to generate some DPTK file.
Okay. I don't know if you have some more question.
There is one.
Yeah.
Are there any plans to include nonlinear implicit solver? So the implicit solver is what is used in radios, is the MUMS solver, so which is not our library, but we are showing it on the GitHub page how to include it in radios. We cannot ship it with OpenRadioss, but we can show how everyone can download it, because it's also kind of freely accessible implicit solver. So please review the discussion board on GitHub for the implicit features of OpenRadioss. Hope it helps.
And you have another question for Francois and Marianne. Does the OpenRadioss plan to have better ParaView compatibility result point file to have smoothie workflow when simulation large model?
So yes, okay. I go with this question. So we are collaborating.
No, please go ahead. Please go ahead.
Between Altair and Kitware, we are collaborating to make the workflow as smooth as possible, especially for using the whole open source workflow. And one key part is the data transfer. So that's why we are pushing BTK HDF file format, which is basically a big container where you can have all your test steps, all your part already extracted, all the fields, and everything is compressed and it's very fast to load in ParaView. And of course, to have one file is better than have one of those files on disk. And HDF is made for distributed and high performance computing. So it means that it could be written in parallel and it could be read in parallel using the ParaView client server with MPI architecture. So it's very convenient. So yes, we are actively working on it, and we hope to announce something in the coming weeks, I would say, maybe days. And of course, as everything is open source, you are very encouraged to contribute. So on the OpenRadioss side, of course, but on the ParaView side also, and in the interface between, you can also contribute a lot, either by using it, maybe reporting some issue or something that works well. It's really a very valid report. And of course, to develop any tools that could help the users to ease their life.
Francois, I think that we missed one question.
Yes, thank you.
Is it possible to create a user toolbar, for example, for automatic extraction of part?
Yeah, definitely. In ParaView, you can create your own toolbars. The whole interface is scriptable in Python. So it means that you can automate lots of action with one button. For instance, in your workflow, you are always opening 4 views with this kind of filters, this kind of things, surface extraction, and so on. You can create once, record a macro of what you did, and then every time you will reopen the data, you just have to, with one click button, click on it, and everything will be created automatically for you. Yes, so this is very flexible, the interface. You can also create some toolbars with the frequent filter you use always. And of course, with the macro system, you can also develop some dedicated plugins. So this is very advanced customization of ParaView, when you can create a dedicated application for your workflow. So you can remove menus, you can get dedicated panels and so on, but based on ParaView. And so there is some documentation in the ParaView documentation and ParaView source code. And if you are interested by doing that, please contact Kitware. We will be very happy to help.
And we have another question from Philip.
We have also one question here.
Yeah, what is the best way to convert a lot of VTU files into a single binary ParaView file? I noticed that bunch of VTU files display slowly.
It depends of your case and your hardware. So there is a lot of file format available. So currently, I would recommend the VTU at the moment, and we are moving to VTK HDF. Would be definitely faster in order to avoid the number of file explosion on disk, which is not scalable.
Okay. Is there any other question?
I think here's one interesting question. Also, can old RAD files work with ParaView? So, yeah, again, ParaView uses the results of OpenRadioss simulations. So you can run also older RAD files with OpenRadioss, and the results will be in the most recent version. So ParaView then will be able to use these results from your old models.
Okay. Was there any question? So what's happened? We are going to close the webinar. Marianne, Francois, what do you think? Yeah.
Yeah.
Yeah. So perhaps
anyway.
Eric want to.
Yeah, not a question, but maybe just a comment. That is, I am really happy that we were able to make this webinar. I think that we got the idea at TerraTech, okay, and it's great to see it make it happen. So a big thanks for CCFR for all the support and the organization of the webinar. A big thanks for Francois, Marianne, and all the people that were behind the scene and to prepare the webinar. And I think it went really well. I mean, the way I wanted, that is to have the experts making a presentation on sharing advice, best practice of the tools. Okay, so yes, a big thanks for making happen this webinar. Yeah, very nice to see all the questions in the audience. So thanks a lot for the audience also for your let's say interaction with the experts.
Thanks, Eric. So I'm going to say the words of the end. Thank you, Marianne and Francois, for your interesting use case using HPC and open source software. Also, I want to thank all the participants coming from everywhere in Europe. We are really happy to answer to all the questions. We are trying to also to invite you on our next training. Some are in English. Also,
our next webinar. Some are in preparation also with ParaView and OpenRadioss on an exascale use case with a flying taxi. So we hope to invite you in some move to join us. So thank you very much for all the participants, and take care and see you. Bye-bye.
Bye-bye. Thanks a lot.
Bye-bye.
Thanks a lot.